Let's now take the knowledge that we learned in some of the previous videos and apply it. So what you see on this screen is a soil analysis report from a lab called Midwest Labs in Nebraska. And there were two soils that were sent in, some pond pasture and a hay field, or two hay field. And there's a lot of information on this form. So let's just focus on phosphorus, okay? And the lab, we'll focus on this column right here, right? It's maybe hard to read, but these values are from Bray 1, and they're Bray 1 extractable phosphorus concentrations of 58 parts per million, that's milligrams per kilogram, in this pond pasture soil, or 12 milligrams per kilogram in the hay field. All right, so that's Bray 1. If this lab had run Melic 3, the value should have been about 35% greater based on results of testing here in the state of Ohio. So those values, instead of being 58 and 12, likely could have been 78 and 16. So are these values good if we wanted to plant something in these two fields? Well, let's find out. So you've seen this table before for the maintenance levels for phosphorus for these four crops: corn, soybean, wheat, and alfalfa. In the red here, this is from the previous slide. If these were Melic 3 that were analyzed by Midwest Laboratories, they should have been 78 and 16 parts per million. So are these good values, or are these values good? And maybe they're good, maybe they're not good. I don't know. I mean, I didn't run the test in the laboratory. I'm assuming because Midwest Labs is a relatively reliable lab that the values are good. But what else could be good? Are those values good in terms of any crops needing phosphorus fertilizer application? So let's look at this table here and compare 78 and 16 to this table. So if you look at this table, this is from the Tri-State Fertilizer recommendations. And we use the maintenance approach, meaning that we want our soils here in Ohio and in the tri-state region to have Melic 3 extractable phosphorus concentrations between 20 and 40 parts per million for corn and soybean, and between 30 and 50 parts per million for wheat and alfalfa. So the first soil from the previous slide had 78. We are well above the maintenance range, and so this soil is sufficient in phosphorus, and thus no phosphorus fertilizers should be added to this soil to grow any four of these crops. However, the second soil from the previous slide, if it was extracted using Melic 3, would have 16 parts per million extractable phosphorus. And if you compare that to this table, we are in the deficient range, and thus we need to make up a difference with phosphorus fertilizer, right? So if it was 16 parts per million and we needed to be in the sufficiency range, we could, via difference, calculate the difference in parts per million and convert that to pounds per acre, and then we could come up with that rate. That's the rate we would need to apply, and then we can look back at maybe a solid phosphorus fertilizer and take the target application rate for P2O5 divided by the decimal form of the amount of P2O5 in the fertilizer to come up with a fertilizer application rate for both of these soils if they tested at 16 parts per million prior to planting. Okay. So, whoops. What about every once in a while I like to throw topics in that deal with turf because there's likely turf science majors, people that want to go into the golf course industry in this class. And so finding recommendations for turf in the tri-state region it's not difficult, it's not impossible, but after talking to several people, they probably need to be updated a little bit. But there's two good places to look, and I was pointed in the direction of Purdue. So this table is from Purdue, and if you want to take a look at the full recommendation, I provide you at the very top of this slide the URL code or URL. And so this is from Purdue, the recommended annual P2O5 applications for established turf based on soil test results. And this should be I can't remember if this is Melic 3 or not. Let's make believe it's Melic 3. I should have known this. Here's the soil test results. And in fact, this column right here in the middle would be the parts per million of extractable phosphorus from a test. And if that extractable phosphorus concentration came back between 0 and 13, that soil would have between 0 and 25 pounds of phosphorus per acre. And it tests low. So the recommendation is to apply 3 pounds of P2O5 per 1,000 square feet. If you're normal, the recommendation is to apply 2 pounds per 1,000 square feet. And this is per year, by the way. And if you're high, the recommendation is to apply 1. Okay? It's relatively simple and straightforward. The values may seem low, but these are on per 1,000 square foot basis, which is pretty typical for turf. It's not on a per acre basis, and there's 43,560 square feet per acre. So these values would jump by 43 times, roughly, if you were to put this on a per acre basis. If you want some more detailed information about other ways to approach phosphorus fertilization in turf, there's actually some really good information from Penn State University. And you can look at their turfgrass fertilization basic guide at that URL at the very bottom of this slide.